Okay, me again. So, let's say you've got your 32. Now, using individual resources, for example, the cubes or the counters, you need to first of all make the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I've lost count. First problem, losing count. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Then, so you've made the 32, then you've got to share them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, I think. 21, yeah, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. And as you see, some of what I'm doing is deliberate, some of it's actually not. It's really quite hard to use that method for any size of number because of how easily it is to get mixed up, to lose the count, etc. So, when you've got anything, I'm saying bigger than 20, you need something else. And what you need, in the perfect world, what you need would be money. Money because it's got bigger numbers, and also because you can combine some of the maths work with money work. So, back to the 32. If I get 32, we know needs, or we will know, needs how many tens? 3 tens. So 1, 2, 3. That's 30. How many ones do we need? 2 more. 1, 2. Okay, so we've got the 32. We've only got 5 things on our table, not the 32 things. So again, we need to do the equal sharing. 10 over there, 10 over there. First problem, what to do with this? Now we could literally tear it in half, but that doesn't really do us any good because it still looks like 10 there and 10 there. So what we need to do is we need to change this for, what do we change it for? 2 5s. So we get the 2 5s. 1 5 over there, 1 5 over there. We've still got the 2 singles that we need to share equally. So 1 there, 1 there. Okay, so we've shared out the 32. Now we need to count how much there is on each side, or each half. 10 and 5 is 15, add 1, 16. Is it the same on this side? Yes. So that's how I'm looking to share bigger numbers, primarily by using money. These 10 sticks, you can do the same thing, but the 10 sticks, there isn't a 5 resource. It's 1, 10, 100 and 1,000. The money's perfect because it's got 5s and it's got 20s. So if you're looking for a recommendation, then I would say money. Use money to help with a lot of the maths work actually, but certainly it's perfect for halving. There are little tricks for halving as well. I say little tricks because mathematically it's maybe not the perfect thing to teach. For example, if both, let's say we've got 48. Not written like that, boy. Okay, 48. If both digits, and when you get into hundreds, if all three digits are even numbers, then you just need to have each digit individually. Now this is something, this column work is something we're beginning to do for addition and subtraction. And I was saying to one of the girls the other day that column addition and column subtraction will be the normal method from year 3 onwards, high school, university, etc., etc. But for just now, thinking about halving, so if I do little arrows coming down, and what we have to do here is we have to do half of 4, which is 2, and then half of 8 is got it? 3, 2, 1, 4. So, half of 48 is 24. This little method, I'm calling it a cheat because it doesn't really give you perhaps an understanding of place value. It doesn't really give you an understanding maybe of what the tens mean, what the tens numbers, the ones numbers. But it's obviously a quick way to do halving if you've got quite big 2-digit numbers. So you can do that, and it is something I will show in the class. Haven't really done it yet, but will do. For having 2-digit or 3-digit numbers, again, if they're odd, if they're even numbers, you can do this. If they're odd numbers, by which I mean if the tens number is an odd number. So for example, the 32. Then the money method is good, works well. Coming back to what I said at the beginning, as much as possible, there needs to be some automatic knowledge of doubling and halving, and how double 10 is the same as half of 20. And it's important that there is that automatic knowledge, the mental maths that they have without needing resources. Okay, I think that's it for now. Probably more later, but for now, bye-bye.